Do you think it's a fair question?
I think yeah, I think it's a pretty fair question.
What's up, everybody? Coding Jesus here. Guys, in today's video, I have with me one of my patrons, John Ling. John has volunteered to take part in a mock technical interview. The question we'll be going over today is effectively classified as, I would say, between a medium to slightly hard for a junior, a medium for an intermediate, and I would guess you can say an easy for a senior. This is not some fancy leet code. It's more about implementation. So John hasn't seen the question yet, but I'm going to send him that question now. John, just for some context as well, is also planning to break into the space of quantitative trading, and so he volunteered for this interview. So John, I'm going to send you a link to this coder pad um,
Yeah.
right here, and invite. Cool. I will generate a short link. I will copy this and put it in our Google Meet. And let me know when you have it open.
Cool.
By the way, guys, half this interview will most likely be behind my Patreon paywall per se, or for my patrons. The first half, the primary coding part and the question part, will be for free for people watching on YouTube. All right, so let's take a look at this. So this problem is essentially implement a unique pointer. At the same time, I would also like to discuss what a unique pointer is and ask some questions for you, John. Let's first read over the entire question set together, and then we'll go step by step. Oftentimes, candidates see the entire question, they get overwhelmed, but I'm really going to walk you through these questions one by one. If you're not sure or you're stuck and there's no way for you to move forward, I will step in and help. The reason I want to do that is because there's really no point in having somebody in a mock interview for the purposes of teaching people on YouTube that just doesn't know what they're doing and is stuck. So let's go ahead and review this together.
Hmm.
So I'll read the problem statement, and then you can ask any questions. So your job is to implement std unique pointer in the CJ namespace, which exists in the header memory. I think the markdown removed memory from here, but it exists in the memory header. Do not worry about implementing a custom deleter. You can use std default delete if you'd like, or you can take some other approach. It's up to you. In other words, don't worry about making unique pointer capable of managing arrays. Your implementation of unique pointer should include these three categories of APIs. Category A, member functions like release, reset, swap, get, bool, dereferencing operator or star operator, arrow operator, equals and not equals. The second category will be the rule of five based functions. So you may or may not include a constructor, destructor, move, or copy operators. You might include some of them. You might delete some of them, up to you. And the last category is the non-member function make unique. Now, before we even get to kind of the questions that I'd like to ask, the more qualitative questions, the not implementation based questions, I want you to take a look also at the test cases. I've obviously commented out these test cases just so that you can run this code and it's not going to crash immediately. But effectively, this is what your code should be doing. So if you look at the first test case, we're just creating a unique pointer, right? So of type int, and I pass in 10 to it. Okay? This should actually be, we're not going to take in a row. We're going to have a constructor that takes in this, a pointer, a raw pointer. So this will also be the next one, new int. New int 10. Okay, and there's a couple of require statements. Each section of this test case specifies what each test should be doing, etc., etc. So, do you have any? Or before I even get there, before I even ask you if you have any questions, did what I said make sense so far in terms of what's required?
Yes.
Okay. Do you have any questions for me?
No, I think it's good.
Okay.
Mhm.
So, I will essentially let you go through it. And when you're going through it, I'd like you to kind of vocalize what you're thinking. I don't want it to be 30 minutes of you just being quiet. So where it says implement unique pointer here, essentially what I'd like to see is, your classes, maybe you template it. I mean, you're going
Mhm.
to need to because it takes in a template type int, for example. So
Yep.
I'll let you go ahead on line 9 and you can walk me through your thought process where it's appropriate.
Oh, gotcha. Okay, so we don't have to talk about the questions here.
Oh,
Like,
sorry. You're right. Let's say you're
yeah,
right. Let's first jump to the questions first, because oftentimes, guys, before people even tell you to code, they're gonna ask you a couple of questions. So my first question for you is what is unique pointer?
yeah. So a unique pointer is a smart pointer, that represents a sole or unique ownership of an object,
Okay.
um, that you have dynamically allocated on the free memory store.
Okay.
Yeah. It's basically just represent unique ownership. Like you can't have like two unique pointers that point to the same thing. Yeah.
Okay. Um, how does it differ from shared pointer?
Yeah. So shared pointer is another smart pointer. It represents shared ownership to a dynamic allocated object. So you could have more than one shared pointers that point to the same thing. And then internally, C++ will do reference counting to determine when this object should be freed.
Okay.
Yeah.
What advantage is there of using unique pointer over raw pointers?
Yeah. So a unique pointer would make sure that the memory is deleted for you automatically when you are no longer using it, as in you don't have any references to it anymore.
Okay.
Um, yeah, so when you use a raw pointer, you have to do the deletion yourself.
Okay.
Um, yeah,
That makes sense. What happens when somebody would try to copy a unique pointer? Is that allowed?
it's not allowed. I do not believe the code would compile because the copy functions should be deleted.
Okay.
Yeah.
What happens when a unique pointer goes out of scope?
When it goes out of scope, it should basically its destructor would be invoked, which would delete the object underlying the unique pointer, either using the default deleter or a custom deleter you pass in.
Okay. Because you're doing well, I'm going to add another question for you here. So let's say I have this,
Hmm.
right? And then let me just include memory just for the sake of this example. So let's say I have this, int pointer,
Hmm.
and then I do like stud unique pointer int pointer one, pass in p, and then stud unique pointer int pointer two, and I pass in p. What sort of issues do you see here, if any?
Yeah. So what happens is that um, unique pointer constructor has no way of knowing like if you have already created an existing unique pointer.
Mm-hmm.
Um, so we would actually get double delete in this case.
Right.
Yeah, and unique pointer. Yeah, so the recommended practice is basically to use make unique,
Mm-hmm.
which I believe is introduced in C++14.
Yeah.
So that way, basically, like you would allocate the memory inside its own constructor in a
Mm-hmm.
safe fashion. So
Okay.
you would handle exceptions gracefully. Yeah.
Yeah, that makes sense. So you mentioned make unique was, brought in C++14, which is correct. When was make
Mhm.
shared introduced?
That's, I believe, C++11. Yeah, I'm
Okay,
pretty sure
yeah,
about that.
that's
Yeah.
right. Okay,
Mhm.
cool.
Yeah.
What is the size of a unique pointer object?
So unique pointer is a zero overhead abstraction in C++,
Mm-hmm.
meaning that it actually, you can basically, in terms of overhead, no matter time or memory, you can think of it just as a raw pointer.
Right.
Yeah, the way it's able to achieve that is via empty-based optimization. Yeah.
Okay.
Hmm.
Um, Now this is a harder question. I don't. You did very well so far, but if I was to ask you to write a unique pointer that has a custom deleter, like I'm not saying implement it. I'm saying write a unique pointer that does have a custom deleter. So you see here in this IntelliSense, I'm not sure if you can see it, but
I can, yeah.
you can see it?
Oh, in Talis, like the
Uh,
pop-up? No,
yeah.
I can't.
Okay.
Yeah.
Well, if you go ahead and write unique pointer and then start with an opening bracket, it takes a type and then it takes a custom deleter. The custom deleter has a default parameter or default value, which is the default deleter, std default deleter. If I was to ask you to, use std unique pointer with a custom deleter, would you know how to do that?
Um, yeah, so let's see. That's definitely a harder question for sure. I think, let's see, you said it's templated. Um, I imagine it's probably similar to the allocator pattern. So I imagine we give it a class that has I think we give it a class, a struct, or a class that has a public co-operator.
Okay.
We can pass a pointer to, and
Could,
then template has to match.
can you try that? Can you try to implement that? Just like using std unique pointer over there, yeah.
I think we probably do something like
And
let's
it
see.
doesn't have to be the custom deleter doesn't have to be templated. It can be hard coded for int, for example. So unique pointer.
You say try to implement that instead of using it, or
Just use it, yeah.
oh, okay, cool.
But I mean, you'd probably have to implement the custom deleter
Yeah,
as unique. It could be an int type, unique pointer of type int.
gotcha. Okay. Let's see. Put this custom deleter here, and then the custom deleter itself needs to take. I can definitely easily make it templated.
Sure.
Yeah. Great. So take a T pointer. And say if I just like, oh, actually.
Call operator. You're kind of close so far. Call operator is brackets, right? So it's operator brackets, and then you just add like, no, not that. Sorry, not parentheses, not brackets.
Yeah. Right. One is parameter and one is like the
Yeah, exactly.
distance.
Sometimes it confuses me too. Okay, and then custom deleter. What does it say? Template use of class. So yeah.
Yeah.
Okay. Cool. Cool. Yeah, that's all I was really interested in seeing. Okay. Now let's get to, so good job there. Now let's get to the actual coding. So I'd like you to implement the unique pointer in kind of the CJ namespace. The best way I would go about thinking about it is, I guess, kind of just look at my test cases to see what I'm testing. But at the same time, let's actually start off with the category A member functions.
Yeah. Sounds good. I'll just quickly look through.
Sure.
I see. So we do need to implement.
Or you can start with category B. It's up to you.
Gotcha. Okay. Let's just check to see. Yep. Okay. Yeah, I think it's looking good. Cool. Okay. All right. So let's see. We're gonna make a class. I'm just gonna call it unique pointer since it's in the CJ namespace.
Sure.
Yeah, and then still gonna use private public just for good practice. And then member functions. I see. So we don't have to worry about constructor. Okay. I promised the right one. Let's see. So this is the constructor that has to do initialize some member variables. Obviously, one constructor. Okay, so yeah, this one could. So unique pointer probably has a couple of constructors. Here we have to take in a raw pointer.
Right.
I do need to make it templated.
And I think you spelled unique wrong. Just so you know the.
My God.
It's okay.
Automatic fail.
No, that's all good. And then one of the constructors, line 14. Yeah.
Cool. Okay, so yeah, so templated. Okay, we're gonna name it T. And then here I'm gonna take in a raw pointer. And then I imagine, yeah, I'm gonna make a let's see, so underline pointer. Here I can use the initialize the list. Let's give it a variable name. Cool. And then this one, by default, it could just invoke the other constructor passing a null pointer.
Right.
Using null pointer type. Cool. And then, yeah, so that could be our constructor. Yeah. So right now I'm not implementing a custom deleter
Mm.
because you said we don't have to worry about that
Right.
for
Don't
now.
worry about
Yeah.
that.
Cool. And then now let's see. Cool. And then let's see. I can, yeah. So that should allow us to do some like basic testing basically on the constructor. So I can go ahead and implement the class A member functions.
How about what I think might be easier for you is if you continue with category B.
Oh, okay.
Is do you need to implement anything else?
Yeah, yeah. So we definitely need to implement a destructor.
Mm-hmm.
And just based on the rule of five, I'm gonna go over all of them.
Yeah.
So for the destructor, right now we can just use a we can just use the default delete. Yeah, I believe that should be good. And then I'm gonna delete the copy operations.
Mm-hmm.
So the first one I need to delete is gonna be a copy constructor. So it's gonna take a unique pointer. That is a other. Should I make it const? Copy constructor. Yeah, yeah, yeah. And then the other one is a copy assignment operator.
Mm-hmm.
Okay. So this is also a const ref. And then I'm going to delete it. Copy assignment should return, I believe, should return itself.
Mm-hmm.
Let's see, so reference,
Yeah.
cool. And then the move functions. Let's see, so when it comes to move one, this is an our value here we have.
Mm-hmm.
What I can do is to basically learn this trick from you, stood exchange. I thought
Mm-hmm.
that was pretty cool.
What header is stood exchange in?
It has a header. I guess that would be algorithm.
It's in utilities.
Oh, interesting. Interesting. I can't believe I have to include the header just to use just to use stood exchange.
Yeah.
It's actually a pretty simple function.
Right.
Yeah. Hopefully, maybe module would help. I don't know. Yeah. Cool. Let's see. So what I'm gonna do is that the underlying pointer would be equal to exchange, and then get their underlying pointer as well as no pointer. So
Yep.
this one just basically sets the other one to be in a valid state. You would have no pointer.
And then just explain for those that might have not don't have exposure to stood exchange what's going on. So you mentioned that it sets other underlying pointer to null pointer, but before that, what does it do? Like it needs to.
Yeah, so it basically takes two parameters, A and B.
Mm-hmm.
What it does is that it would return the old value
Yeah.
it would return the old value A. A would be set to B
Mm-hmm.
before returning. Yeah,
Okay.
cool. Yeah,
All right. And then the.
yeah. It's honestly just saving me like one line of code.
Yeah.
Yeah. Okay. And then I think for the let's see the move
Move assignment
assignment
operator.
operator. Yeah. So let's see what I need to change it to. Okay. Move assignment operator. I should be able to do the same thing. It looks like I just need to, yeah. Like, oh, wait a second. I need to probably delete the whatever I had. Yeah, that makes sense to me. Yeah, I need to delete whatever I have.
Mm-hmm.
Yeah. So it should be safe to delete no pointer. So I'm just gonna directly invoke my own destructor here. Yeah. Delete whatever I have and then do the assignment. Yeah. So that should be good.
I've actually never seen a use case where you call the destructor from another method. Um, I prefer instead of doing that because I'm not sure what implications that has. Instead of doing that, what I prefer you do is you refactor the delete underlying pointer in the destructor to another method, and then just call that from both the move assignment and the destructor.
Oh, okay. Gotcha.
I'll need to look into that myself.
Delete underlying pointer.
Yeah, I prefer you do it that way.
Yeah. Cool. Done. Yeah. Yeah, I think that makes sense. Just in case the destructor does something that's like, because you should assume that nothing else, this object wouldn't be used anymore.
Yeah, yeah. You also don't want to couple it to the destructor because maybe you want to do cleanup, but not necessarily cleanup that is required in the destructor. There might be other additional cleanup in the destructor you don't want to run in the move assignment maybe.
Yeah, that makes sense.
There is. Are you done in the move assignment operator or no?
Let's see. I think yeah, I think I'm done. Yeah.
What about the return value?
Oh, sorry about that. Wait, why it didn't even warn me about it? Fun.
Yeah.
Okay.
Do you have to do any checks for whether or not you know what I mean? The
Oh, that's a great
other,
question. Yeah, since I'm deleting the object, yes, yes, yes. Great. Yeah, great question. Yeah, because usually like um sometimes it might not be worth doing the check, but here since I'm doing a deletion,
yeah.
yeah, yeah, sorry.
And
Yeah.
just so you can explain to others why are you making this check?
Yeah, so typically I think in school, computer science classes would say that, when the object you're trying to, when like the user somehow tries to construct an object from itself, either via the copy constructor or the move constructor, I mean the copy assignment operator or the move assignment operator, you could just do a check and skip the operation.
Mm-hmm.
And then like sometimes it's not necessary to check just because it actually doesn't you just can avoid a branch instruction there, but in
Mm-hmm.
this case because we are actually deleting an underlying pointer, if the parameter is the object itself, same as this, then we would actually no longer have a reference to the underlying pointer and the object will be freed, so we
That's
we,
exactly
we
right.
lose the object
Cool.
forever.
Now, does this method does it the return value is a reference, right?
Yes.
And you're returning a.
I'm returning a I see. I think this is a pointer, so
That's
yeah, I
right.
should dereference it. Yes. Yeah. Here as well.
Mm-hmm.
Wait, I'm so surprised. I kind of just assumed like the copad would actually tell me.
Yeah,
Yeah.
yeah. This is a free version, I guess, so it's not as advanced.
Oh, okay.
Yeah,
That's
I think
more
that
more
might be the
challenging.
reason.
Gotcha. Cool.
Okay. Sounds good. This makes sense to me for the rule of five. Now let's talk about the member functions.
Yeah. So member functions, I think, gonna be easier. Just because I use them a lot more.
Sure.
Yeah. So now in terms of the member functions, oh yeah, I'm pretty sure they should be lowercase. Yeah. Okay. Cool.
Yeah, I mean, they don't have to be exactly the same. Let me see. Yeah, they should be lowercase 'cause in the test case, they are lowercase.
Yeah, I was just checking that. Cool. So in the release one, okay. Yeah. Now this is testing my understanding of the differences. Release, I believe, should basically release the underlying pointer as well as giving up the ownership.
Mm-hmm.
Yes. Cool. So what I'm gonna do is that let me think about what's a good. So I'm basically setting it to no as well as returning it. I guess I could just make a temp variable. Yeah. There may be like a something like Steward Exchange that can do it.
Yeah, so why not just use Steward Exchange?
Let me think. Oh, temp does let's see Steward Exchange. Oh yeah, that could work actually. Yeah, that could work. I just call it on my own underlying pointer.
Yep.
Yeah. Okay. Yeah, so that should do it. Neat. And then let's see, we have reset. Reset. Let me double check the test cases we have, if we have any reset. Let's see.
Yeah, reset actually I think has 2 overloads. Let me just double check myself. It's fine if you, usually in interviews, they're fine if you look at documentation just simply for like the method use cases. In most cases, sometimes they might say no, but let me take a look. Yeah, yeah, reset has one that, oh, yeah, reset does have one since, reset does have one that takes no parameters, but most of them do take a parameter.
Yeah.
So for the sake of, I'm gonna add one more test case. So you can implement both. So the no parameter and the parameter one. So reset unique pointer with new object. So effectively, I'm gonna do. It's gonna require. So you see my new test case?
Yes.
Cool.
So I actually do not remember the return type of reset.
You can look up the.
Oh, okay.
Well, let me tell you because I have the page open anyways. So return is void.
Oh, cool. So I got it. Nice. Yeah. So in this case, I believe I think let's see. So what I can do is just to set the underlying pointer to actually reset. Reset. Yeah, I should actually free it. Yeah. And then that's it, I think. Yeah. Let me think about this. Would it be a good idea for me to set the underlying pointer to null? It could be. Yeah, if the user calls reset twice, maybe that's a good idea.
Yeah.
I don't know if Steward unique actually does it, but I think I can do that. Yeah. So I added to do here. Is this necessary?
It doesn't have to be. So the thing that even I learned from my own personal mentor is that when you implement like a data structure that is in CPP, in C++, like if the interview question doesn't explicitly say like this is the way you should implement like delete underlying pointer, for example, then you can add your little kinks and twerks to it to make more sense to you. So if deleting and then setting to null pointer makes more sense to you, that's totally fine. It doesn't have to be like, how does the standard exactly do it? Let me go look at the source code.
Gotcha.
Yeah.
Cool. Yeah. So we just reset, and then yeah, I'm actually pretty sure standard will do it. Yeah, just make a lot more sense to me if it does that. Yeah. So and then here we have to take in, I believe, another raw pointer, and then let's see. So we need to delete as well. So in this case, the pointer, underlying pointer, can just be set to the new pointer we are resetting it to.
Yep.